All right, 5.6b, inverse trig. We're going to do derivative style today. All right. Coming up after the derivatives, guess what we're going to do with them? We're going to integrate them. All right. So here we go. So our picture here is y equals arc sine of x. Y is equal to arc sine of x. Now, if we did this, how could I get to x? How could I get to x? I sine both sides, right? It's the inverse operation. So if I sine both sides, now I have sine y is equal to x. Everybody agree with that? Yes. So now I have sine y equals x. Now I can take a derivative of that. So what's the derivative of sine y with respect to x? What's the derivative of sine? Cosine. So we'd have cosine y, but if it's with respect to x, what also gets to pop out? A dy dx. And then what's the derivative of x? 1. So now we end up having cosine y dy dx is equal to 1. Agree? Yes. So then how do I solve for dy dx? Divide by what? Cosine. So then we divide by cosine. So then we end up having dy dx is equal to 1 over cosine y. Well, what the heck is cosine of y? Square root of 1 minus x squared. And so we'd end up with my derivative would be 1 over square root of 1 minus x squared. But what is y originally? Arc sine of x. So the derivative of arc sine of x is what? 1 over square root 1 minus x squared. All right, that's how it was formed. Let's prove a couple more. So now we have arc cosine. So let's draw our little triangle. So what is cosine? Adjacent over hypotenuse, right? And so what would be my adjacent? Say x. Good. And then what would be my hypotenuse? 1. So then what's my opposite side?
1 minus x squared.
Square root of 1 minus x squared, right? Pretty good? So then I don't know the derivative of arc cosine right now. I can't take a derivative of it yet. We're soon going to just use our note card, but I want to show you where it comes from. So how do I get to x? Cosine both sides. So now I have cosine of y is equal to x. Now could I take a derivative of cosine? Yes. What's the derivative of cosine? Negative sine y, but what pops out? Dy dx. And what's the derivative of x? 1. Have I solved for dy dx yet? No. Not yet. So dy dx would equal what? Can I call it negative 1 over sine y? Yeah. All right. So now if I look at my triangle, what's the sine of that y? Square root 1 minus x squared. So now my derivative would end up being negative 1 over square root 1 minus x squared. All right. So if y is equal to arc cosine, guess what the derivative is? Negative 1 over square root 1 minus x squared. All right, let's do one more. Let's do arc tangent now. So I'm going to show you how it's proven on this one. So now we end up having arc tangent. So what is tangent? Opposite over adjacent. So my opposite is x, my adjacent is 1. So then my hypotenuse is what? Square root of 1 plus x squared, or x squared plus 1. Either way. So now, I can't take a derivative of arctangent yet. I don't know it. You don't know it. So then, what do? How do we get to x? We tangent both sides. So now we end up having tangent of y is equal to x. Well, do we know the derivative of tangent? Yes. What's the derivative of tangent? secant squared. So now we have secant squared of y, but what pops out? dy dx is equal to 1. So what do we want to do now? We want to solve for dy dx, so what do? Divide by secant squared. So now I have dy dx is equal to 1 over secant squared. Now, I personally don't think that makes any sense. It's not an x, it's a y. I don't like dividing by secant squared. I think that's silly. So really, what do we have there? It's cosine squared. So this is the same thing as saying cosine squared of y. You got it? I know you did. All right, so now let's evaluate it. So now we end up having dy dx is equal to, what is the cosine of y? 1 over the square root thing. So now we have 1 over the square root of 1 plus x squared. But what do I want to do to it? I square it. So when I square it, what do I get? I get 1 over 1 plus x squared. So the derivative of arctangent is 1 over 1 plus x squared. All right. I've just proved 3 of them. Pretty nifty. All right. Get out your note card. We're going to add to it. So let's flip it over to the back. I do want you to save some room here. You're going to have 6 more come Friday and Monday. All right, and then that will be it. I promise. All right, so the derivative of arc sine is 1 over square root 1 minus x squared. However, I just put it in terms with the chain rule. So we always have to remember the chain rule. So we'll have a u prime popping out.
Wait, good idea.
All right?
We don't have to leave space for an interval, right?
No.
Should.
So now let's use them. So we're going to derive arc sine of 2x. What do we always need to be worried about? Chain rule. So here we go. Just look at our note card. What is my u? 2x. So now we just use our note card. So we have square root of 1 minus what? What do we have on the bottom? Do you see how we're just using our note card? It's right, like literally right there. 4x squared. There it is. Does anything pop out? A 2 pops out. So we done. See how that worked? All right. Let's look at this next one. We're going to derive arctangent of 3x. So we're going to take the derivative of arctangent of 3x. Now, could we build our triangle like before?
Yes.
You could. We don't have to. We're just going to start memorizing these things. And by memorizing, I mean literally using your note card for right now. Okay? So, on the denominator, I have 1 plus what? 9x squared. But what pops out? 3. And we done. Pretty good? All right. Fantastic. So let's look at this next one. We're going to derive arc sine of square root x. We're going to derive arc sine of square root x. So let's just substitute in square root x for now. So we end up having square root of 1 minus what? What? Just x, because it's square root x squared, right? So square root x squared is just x. However, what pops out by the chain rule? No. 1 over 2 square root x. Exactly. The derivative of square root x is 1 over 2 square root x. Because a 1/2 comes out front, and then what happens to that power? It goes to -1/2, right? Now, I personally like it looking like this. I truly like the square root thing. I truly do. However, they might not put that on the AP exam. They might combine them. And so if they were to combine them, it would be 1 over 2, and then it'd say square root of what? X minus x squared. All right. I'm personally fine with the one in the blue, but they will probably go to the one in the black. You following me? All right. All right, so let's look at the next one. So now I have arc secant of e to the 2x. All right. So we didn't prove arc secant or arc cosecant. However, we're just going to just use them. So we're looking at that guy right there. So now I have absolute value of e to the 2x. And then I have square root of e to the what? E to the 4x. Remember, a power to a power, what do? You multiply. All right, and then minus 1. All right, and then what's my du or u prime? 2e to the 2x. Now, they will not have that on their answer. What happens? The e to the 2x's cancel. So they're going to be leaving it with 2 over the square root of e to the 4x minus 1. I want to talk about a couple things now that we have this. What's the difference between an arc sine and an arc secant? What's the difference? I don't want the absolute value. Don't care about that one. Because do we have an absolute value here? No. So it can kind of be like hidden a little bit. What's the difference between an arc sine and an arc secant? I truly want to get this before we move on.
Oh, it's u squared minus 1.
What?
1 minus u squared.
Exactly.
Wow.
All right. Arc sine is 1 minus your variable squared. Arc secant is what? Your variable squared minus 1. That's going to be your giveaway on these when we start working with them further. But I wanted to hit it right now. So what's arc sine? It's what? 1 minus your variable squared. Arc secant is what? Your variable squared minus 1. Because this absolute value thing, sometimes it shows up and sometimes it doesn't. You following me? All right, it's there, but like sometimes it's like hidden. Okay? All right, here we go. We're going to find the derivative of this guy. All right. So we have y equals arc sine x plus x times square root 1 minus x squared. And this one plays extremely nice or mean depending on how you look at it. All right. All right, let's take a derivative. So how do I notate taking a derivative? dy dx. And what's the derivative of arc sine? What do I have on the bottom? Square root of 1 minus x squared. Does anything pop out? Not really, just a 1. All right, so we just got a 1 over there. However, what do I need to do to the right side? A product rule, exactly. So what's the derivative of my first? 1. And then I'm left with square root of 1 minus x squared. And then plus, now I need to take the derivative of square root 1 minus x squared. So what gets brought out front? A 1/2. All right, and then what does that power go to? Negative 1/2. So now that goes to the basement. So now I have a square root 1 minus x squared down there. Does anything pop out? Not 2x, but a negative 2x. Very good. All right, so a negative 2x pops out. And then what do we multiply by? X. All right. Does anything happen? I don't know why that one's red. Does anything happen? The 2's cancel. All right. All right, so now we need to start simplifying it up a little bit. All right. So we end up having, I'm going to move this first and the third one together. All right. So now I have 1 over square root 1 minus x squared. And then what do I have in my numerator on the right side? Negative x squared over square root 1 minus x squared. And then plus square root of 1 minus x squared. That's my second term, basically. So what's happening right here? What's happening in my first and second term now? They're common denominators, so that's nice. So what's in my numerator? 1 minus x squared. So I have 1 minus x squared over square root 1 minus x squared. So what is that? I have a power of 1 over a power of a 1/2, basically. So I just have what? I just have square root of 1 minus x squared. And then I have plus square root of 1 minus x squared. So what do I get? I get 2 of them. So dy dx is equal to 2 square root of 1 minus x squared. All right. Pretty good? All right. All right. Miller's going to read.
An officer in a patrol car sitting 100 feet from the highway observes a truck approaching. At a particular instant, t seconds, the truck is x feet down the road. The line of sight to the truck makes an angle of theta radians to a perpendicular line to the road. Express theta as an inverse trig function.
Let's do it. Let's do it. So, this theta right here, this x is my what side? Opposite. This 100 is my adjacent. So what could I use? Tangent. So it's not going to be tangent. It's going to be an inverse trig function. So theta is equal to arctan of x over 100. All right. So theta is equal to arctangent of x over 100. So now I'm going to find d theta dt. All right, so let's take a derivative. So d theta dt is equal to, what is the derivative of arctangent? I'd have what on the bottom? 1 plus what? My variable squared. So what is my variable squared? X squared over 10,000. Good. All right. And then what would pop out by the chain rule? 1 over 100. What else pops out by the chain rule? Something else pops out. What is my equation in terms of? X. What am I taking it with respect to? T. So what else pops out? Dx dt. All right. So dx dt also pops out implicitly. All right. So, all right, because I'm going to be working with this one, I don't want a fraction. I don't want a complex fraction. So what could we multiply this whole thing by?
10,000.
10,000 over 10,000, because we're essentially multiplying by 1. So up in my numerator, I'd end up with what? 100. Over 10 plus x squared, and then I have dx dt. All right, so I personally would move it like that. All right, so then let's look at part C, and Gunner's going to read that part.
When the truck is at x equals 500 feet, the angle is observed to be changing at a rate d theta dt equals negative 2 degrees per second. How fast is the car going in feet per second and miles per hour?
All right, first of all, I think this problem's slightly rude because it gives you in what? Degrees per second. What is the measure of angle in? Radians. So guess what we need to do to convert degrees to radians? How do we convert from degrees to radians? We multiply by what? Pi over 180. So we multiply negative 2 by pi over 180. So then we'd end up with what? Negative pi over 90. So d theta dt is equal to negative pi over 90 radians per second. All right. All right, so now that we have that, that's my d theta dt. So now I have negative pi over 90 is equal to 100 over 10,000 plus, what's my x? 500. So what is 500 squared?
Hi, Jake.
All right. All right. So then the bottom would end up being what? 260,000. We'd multiply by its reciprocal, and we end up with dx dt is equal to negative 90.7571 feet per second. All right? Why is it negative? Why is it
Because
negative?
it's going.
The distance between the truck and the popo is decreasing. So that's why it's negative. But how fast is it going? It should be a what? It's talking about speed. So it should be what? The absolute value, so it's positive. All right. Pretty good?
Yes.
If you wanted to know, that's 61.8798 miles per hour. All right. All right. Let's keep moving. So, we have now figured out all the derivatives of all the elementary functions. I know it sounds kind of rude to call them elementary functions. You're like, I'm in calculus. However, they are kind of basic in comparison to a lot of things. All right. So, we have Galileo Galilei. I'd like somebody to read. Doug is going to read for us. Thank you so much for looking up from your phone.
Galileo's approach to science departed from the accepted Aristotelian view that nature had describable qualities such as fluidity and potentiality. He chose to describe the physical world in terms of measurable quantities such as time, distance, force, and mass.
All right, fantastic. Thank you for your contribution. So now we know how to take derivatives of all of these things. So if we have a constant, we can bring it out. If we have just adding or subtracting, we have a product rule, we have a quotient rule, we have a constant, we have a power rule, we have a derivative of just a value. We take derivatives of natural logs, regular logs, cosines, arc cosines, all kinds of good stuff. So you actually know how to do all of those things now. You should be very proud of yourself. All right. All right. So there we go. I am going to cross out numbers 100 and 101. And we're also, I said, we're going to do numbers 50 and 63 together. I don't know what those are. So on number 50, it says we're just taking a derivative. What rule do we have to use here? Product rule. So let's do it. So h prime, that's how we notate taking a derivative. What's the derivative of my first? 2x. And then we just have arctan of 5x. And then I take the plus, the derivative of my second. So let's just look at our little note card. What goes on the bottom? 1 plus what? 25x squared. And then what pops out by the chain rule? Of 5. And then what could I multiply with it now? I took the derivative of my second, so now times the first of x squared. All right. And if you're in my pre-calc class that doesn't make it to calculus, they'll be like, oh, let's cross out these x squareds. Don't do that. Okay?
Did
All right. All right.
they do that?
All right, let's do number 63. Number 63. So we're going to find an equation of a tangent line to the graph. All right. So what do we need? A point and a slope. So do we have a point? Sure do. So we need to find our slope. So let's find our slope. How do we notate it? dy dx. So let's just look at our note card. So now we have what on the bottom? Square root of what? 1 minus x squared. What goes up top? Just a 2. Just a 2. Does anything pop out by the chain rule? No, because the derivative of x is just 1. So there's my derivative, and what do I need to evaluate that guy at? The point. All right. It's just an x value, so I'm going to just say x equals 1/2. All right. So when I substitute in 1/2 right there, 1/2 squared is what? 1/4. All right. So then I have 1/4. So 1 minus 1/4 is 3/4. So now I have 2 over the square root of 3/4. Now I could keep going with this because what's the square root of 3/4? Square root 3 over 2. And so now I end up having 2 over square root 3 over 2. What do we multiply by? 2 over square root 3. So then I'd end up with 4 over square root 3, which we could say is? There it is. So there's my slope. So now I have a point, I have my slope, so let's make an equation. So now I have y is equal to 4 square root 3 over 3 times x minus 1/2 plus pi over 3. And now I am finished. Pretty good? All right.